Hey everyone, welcome back to another 7-minute math video.
All right, everybody, let's work on multiplying binomials using the area method. Now, many of you have seen this before, but let's make sure you understand the concept. When you're taking two binomials, 2 items here, 2 items here, those are binomials, using the area model, one option is to draw yourself a rectangle or a square. You're going to take the 2 pieces of the first binomial, the 3a, and the positive 2, and you're going to put them on the left side as if they were lengths of these 2 sections of the rectangle. And then we're going to do the same thing here. This happens to be negative. That's a little out of the ordinary, but we're going to go ahead and put that on the top portion. And we're going to put the numeric version, the -5, on the second portion as well. And then all we're going to do is multiply these 4 pieces together. I'm going to take 3a times -a and get -3a squared and put it right in the box that represents it. I'm going to take 2 times -a and get -2a in the box that represents that. 3a times -5 is -15a, and 2 times -5 is -10. And then normally what you'll do, in most area models, this and this will normally be like term. Now you want to double check, but in this case they both have an a with an exponent of 1, so we're simply going to combine these 2 together, and we're going to write this, this, and this as our answer, or as our simplified expression. So I get -3a squared. These 2 together make -17a, so -17a, and -10 is -10. And that's all there is. That's multiplying using the area model. Now there are a few different designs. Here's an example of a common one where it is, I consider it advanced because the degrees of the 2 binomials are different. But the technique isn't, in fact, I have some ghosting here. Hold on. All right, ghosting is gone. So let's go ahead and write down our area model. And now we'll fill in the spaces. X squared and x to the third is x to the fifth. X squared times -2 is -2x squared. 3 times x to the third is 3x to the third. And 3 times -2 is -6. Now, while I normally look on the diagonal here to combine like terms, notice how the x's have different exponents, so they're not like terms. So I'm just going to write the 4 individual pieces in order from the greatest degree down to the least degree. And there you have it. So that's an advanced problem when dealing with different degrees. Now there's 2 more cases that we should look at. These are special cases in the textbook, depending on what book you're in. In my book, it's page 492. These are called the sum or difference of squares. Now let's take a look at this. This is a plus 3 quantity squared, and what that means is I have a plus 3 and a plus 3 multiplied together. And the key piece here is that you recognize, that this is just an area model question like all the others. This is an a plus 3 and an a plus 3. And we'll go ahead and fill in those 4 spots in just a moment. What it isn't, it definitely is not, is a squared plus 9. This is a very common mistake where students will kind of distribute that squared to both terms. That is wrong all the time and not something you want to do. So instead, think about writing it out. There's 2 of them, so write 2 of them. This is a squared. You can fill in the rest. Combine your like terms. Be done. Likewise, on the minus side, what it isn't is b squared minus or plus. It wouldn't make any difference. I guess if you did -4 and you tried to square it, you might think that it's plus 16, but no, that's not how this works. So I'll do it in fast motion here. Notice the plus 16 because negative times negative. And there you have it. There is one more special case. What you'll see is, in my book again, this is on page 494. You can look that up if you need to. That's the Prentice Hall Algebra 1. It looks, here it is. It looks like this. So if you have this book, you can look it up if you need to. With that in mind, this is a special case because the first binomial and the second binomial are almost identical except for the fact that they have opposite signs. Now, again, if you look on page 494 of that book I showed you, you can find what the actual rule is. For me, I'm not a big memorizer. I've never been good at memorizing, and I don't know that memorizing is a great strategy for lots of this work that doesn't need to be memorized. I'm just going to use the area model. So here we go. And with the area model complete, I'll combine my like terms. Interesting that negative 10x and positive 10x, they're going to cancel each other out because they're both opposites of one another. So we don't have a middle term here. We just do minus 25. And that's how you multiply binomials and binomials.